Hello guys, how's it going? So last time we have worked on getting the parts in the config. So last time we've worked on parsing the config, and this time we are going to start working on video modes, or at least a first step before we get there. As you might have noticed, I did some housekeeping on this code here to actually add some error handling. Instead of the optionals that we were returning, now we have actual errors that are returned by the different functions that we have here. And I've created this error set here, bootloader error, that for now has these three error types. Right, so today we are going to take the first step towards the video mode, and that is selecting the preferred resolution of our display. I'm actually trying to make things interesting for me, but also for you, by making small changes compared to what we did on the buyer side, so that it's not too repetitive. That means that for getting the video resolution, we are going to take a look at the EDID standard. So EDID is Extended Display Information Data, I think. And what I have here is the version 1.4 of the EDID standard. So basically EDID is something that your display has, and any video device will actually query your display for its EDID, and the EDID will have a structure that will give details about the physical sizes of the display, as well as the preferred refresh rates and resolutions. So that's what we are going to do today. So let's get started. First of all, I'm going to just set up this. I'm going to create, I'll call this preferred resolution. And this would be of type, I guess we can just create get preferred resolution, and this actually we can do a bit more. We can catch any error that we return from that function and fall back on the resolution that we have defined in our config, so we can have some use for that. So here we can do maybe log something. I think we don't need to, but let's do it. Let's do it anyway. So standard log error, or let's just make this a warning. Not resolve display preferred resolution falling back on config. Let's say it's something like this, and here we just do that, and we can actually we need to use special syntax here. We need to name this block, just call it block, and here we need to break from block with a value, which would be bootloader config video. That looks pretty good. There we go. So now we just need to create this function here. So let's go ahead, get preferred resolution, takes nothing and returns bootloader error. Otherwise it returns video resolution. And this video resolution is basically just a width and a height. Actually, let me just do something here. Let me remove these two from here and probably just put them here. So this was 640 and height was 480. There we go. That looks pretty good. Right, so here we are now. Let's get started. So first of all, let's take a look at the EDID spec. So in section 3.10, we have the 18-byte descriptors, which give the detailed timing descriptors of the display. And we can have, I think we are obliged to have 4 of those. And the first one is the preferred timing mode, which is basically the preferred refresh rate and resolution and other things. So if we go ahead and take a look at what every one of those descriptors looks like, as we've seen, it's 18 bytes per descriptor, so we'll have a table with bytes numbered from 0 to 17. There we go. But actually, we are only interested for now in these fields here. So here we have the horizontal addressable video in pixels. This field here, this byte, contains the lower 8 bits of the horizontal pixel width. And then we have the horizontal addressable video in pixels. And this one here has the upper 4 bits being stored in the upper nibble. So basically this byte here, the upper half is the horizontal addressable video in pixels, and the lower half is the horizontal blanket in pixels, which we don't really care about. And we have pretty much the same thing here for vertical size. So we have the lower 8 bits in byte 5, and we have 4 additional bits stored in the upper half byte, or upper nibble of this byte 7 here. And those descriptors are actually laid out in the EDID block, starting from address or offset 36 hex, right? So the first one is from 36 hex, so 18 bytes to 47 hex, and then we have 48 to 59, etc. So if we take a look at Appendix A, example 1, we have an example EDID block for some random LCD desktop display. And if we go down to offset 36 hex, which should be here, right? So here we have actually the data being described. So we can see that in byte, in the second byte, starting from the start of the descriptor block, we have horizontal addressable video is 1600 pixels. And the way we find that is we take these 8 bits, and then we take these 4 bits and we put them on top. So for example, so if we go ahead and do so 110, and then we do 01 00, there we go. So this basically taking these 4 bytes and these lower 8 bits, or these 4 bits and these lower 8 bits, we can see that we actually have a value of 1600 pixels. We can do the same for the for the vertical size. So let's go ahead and do that. So if we go back here, vertical size, we have so 100, and then 1011 and 4 zeros. And that gives us 1200 lines, which is basically what they got here. Now, the question is, how do we get the EDID block, right, to be able to get these data from it? And that should be fairly easy, because if we go to our UEFI specification, we can see that we have this here, which is EFI EDID Discovered Protocol. And this protocol here, we are told that it's retrieved from a video output device. So what this suggests is that we need first to get a sort of EFI handle to a device that's capable of the video output protocol, and then we ask it if it handles EDID information or not. So that's what we are going to do right now. So let's get started. Okay, so as always, I think we're gonna start by creating a log. So scopt log, and I'll call this EDID, for example. And then I'm going to create, actually I need these things. Actually, let me just take all three because we need the status. Now, the idea is to get the list of, or a list of all devices that can, that are video output devices, right? And to do that, we are going to ask EFI to give us a handle to all the devices that handle or that support this graphics output protocol. The way we are going to do that is we are going to ask it to locate all handles to devices that support that protocol, which is video output. So let's do that. Right, so let's get the handles. So we are going to need to go through boot services, and I think we are going to use locate handle buffer. Actually, there are two variants of this. There's the locate handle, and there's the locate handle buffer. The only difference is that locate handle buffer pre-allocates the basically the array, the list of handles that it returns us, whereas locate handle, for locate handle, we need to do the same dance that we did for pretty much everything else, where we give it a size of 0, get back the size, and then allocate and pass it the actual size. So I guess for this one, I'm just going to use locate handle buffer. So this takes a search type. So if we go here to search type, all handles by protocol, I think we need to search by protocol because we are interested in the device handles that support a certain protocol. So that's what we need to pass it. So by protocol, and then we need to pass it the GUID of the protocol we are interested in, and that would be graphic output GUID. Of course, this should be passed as a reference. Next, we need a search key, but here, if we read the very next sentence, search key is ignored for this search type. So just pass it null. And then we need to pass it a number or a pointer to a usize. Handles count, or yeah, that should be, there we go. A ref to something called handles count, and then we'll pass it a pointer to two handles. There we go. So we just need to go ahead and create handles count, which is a usize, set its value to 0 for now, and then we need handles, which is a many item pointer to UEFI handle, undefined. Okay, so with this, we have a status, so we need to go ahead and do something like this. Whereas here we need to do graphic output device error. And just go ahead and paste that in there. Right, so expected success. And here we need to change this to found number, I guess, video device handles. Could do something like that. And here we'd have handles count. There we go. So now that we have our handles, what we need to do is basically loop through them and query every one of them for EDID, right? So var I should be a usize, say to 0, and then while I is less than handles count, we do I plus equals 1, and we can go ahead and do so const device, call it device handle is handles of I, and this, of course, I'm just going to give it a type. There we go. So now we need to query this handle that if this handle supports the EDID protocol. So to do that, again, we are going to use something that's in boot services, and that's handle protocol. This basically, as we can read, queries a handle to determine if it supports a specified protocol. So it's exactly what we want. So we pass it the device handle, and we pass it the protocol that we are interested in. That would be UEFI protocol. I think EDID, yes. And then we just go discovered and GUID. And of course, again, I forgot that this should be a reference. Right, and here we need to pass it an interface. So, and I guess this is a pointer to an optional pointer of any opaque. We all know the drill by now, pointer cast, and we cast the pointer to EDID. I'll call it EDID protocol. Oops. There we go. Of course, we need to define so var EDID protocol, and this, of course, would be UEFI protocol EDID discovered, or rather a pointer to, and of course this would be undefined. Right, so here again we need to handle the success, or rather the status. So here we need to do found EDID of size. I think we have the size of the EDID as a member of the protocol. So EDID protocol.size of EDID. There we go. Otherwise, we need to EDID. Should I do graphic? Yeah, maybe let's keep it. Let's keep it graphic output device error. And I think if we go to handle protocol here, handle protocol, there we go. So if we go to handle protocol, yeah, there we go. That's what I was looking for. So it returns either EFI success if the protocol information was returned. Otherwise, it returns invalid parameter if we pass it something weird. Otherwise, we have this error here, unsupported, which means that the protocol is just not supported by this device. So I think we might as well, unsupported, handle this. As a matter of fact, we might not do this here because we are looping the handlers here. So we might just want to no, actually, okay. So let's keep this here. I'm gonna need to add a loop label there. And if we get, so we expect either success or unsupported. And if we get something else, then it's an actual error. Unsupported would just mean that we'll warn that handle D does not support EDID, for example. And here we'll have just I think. Oops. Right, and here we want to do continue of the loop. Actually, I'm not sure we need to do this. I think if I just do that, it'll be fine. Yeah, I think it will. Right. So, if we somehow find something, we go ahead and log info. So found EDID on handle D. And of course, this would be I. And if we found that, we just need to get the actual EDID struct. So const EDID struct, and, or let's actually call it EDID pointer. And this EDID pointer will be EDID protocol.edid. Right. Actually, let's rename this. Just be EDID. Or we can do one better. We can do EDID protocol EDID, and we can capture that in EDID if it's not null. So if we have this, I'll just put here a to do actual EDID block validation, but we are going to skip it for now. So I'm just going to take the X resolution, which will be, as we've seen here, we need to go to, we are going to take the very first detailed timing descriptor, which is the preferred timing mode, starts at address 36 hex. And we know that the second byte gives us the lower byte of the width in pixels, and the fourth byte gives us the upper 4 bits of that. So let's do that. So we want EDID. So at address 36 plus 2, right? So that's the lower 8 bits, or yeah, that's it. That's lower 8 bits. And then we OR that with EDID at address 36 offset 4, and we mask it to just have the upper 4, the upper nibble, upper 4 bits, and then we shift that up by 4 so that we can actually OR it without losing. So basically what this here does is that we take the 4 bytes that are, so for example, 1111 that are at the byte of offset 4, and then we, so let's say for example that we had something like 1010, or let's call it 0101. So what we do is we AND that with 0xF0, which is basically 0B 1111 and that gives us, so just masks off the top part. Actually, let me just change the pattern here so that it's clear what I'm trying to do. So it gives us this, and then we shift it by 4, and that gives us, so 1010, and then we'll have this, right? And then we AND that with, so basically EDID at 36 hex plus 2, which is the lower 8 bytes, or 8 bits, and that basically just takes this position here that has these zeros. So that's what we are trying to do here. Right, so here the only thing that we are missing is actually we might need to cast these things because we EDID is an array of U8s, so that means that this shift here will overflow. So we need to widen that before it does. So let's cast that to U16s, and let's also cast this to U16s. There we go. And this here should be U16, of course. There we go. So we need just to copy this and change X to Y. And we know that the vertical size is in offset 5 and 7 for the upper 4 bits. So we'll need to do, so this one is 5, and then this one here is 7. There you go. And of course, we just need to return, if we found the first one, we just need to return. So width is xres and height is yrres. And of course, here I forgot to do this. Cool. And I think I don't need to specify the type here, because it's going to find it by itself, or is it not? Maybe I need to do this. Yeah, I probably need to cast before I shift. And in doubt about the order of operations here, I'm just gonna force it to do the shift first before doing the OR. Although I think the shift is of the highest priority, but yeah. All right. So this basically is our exit point from this function. And if we cannot find any EDID, we are just going to return bootloader error. So what's a good error? EDID not found error. And I'll just put this here, and that should be good. And of course here we are, we have this unused error. So let's do std.log info using resolution. There you go. Of course, we need to give it the actual resolution. So width and preferred resolution height. There we go. So let's try to build this and see what we have. All right, so we are building. Let's see if we can run this. All right.
Many hours later.
So I did some research, and it turns out that OVMF does not support EDID. So yeah, it's sad. And I don't really feel the urge to compile my own EDK2 to add support to that, at least not for now. So I will try to test this on real hardware and debug it there. But I think with our fallback on the parsed config, we should be fine to continue. It's fair to say that it's sad that we couldn't test that our implementation works. I'll probably do a follow-up once I can test this on real hardware. I also want to thank you who are supporting the channel. It really motivates me to keep working on this kind of content. So thank you. And until next time, I'll see ya. Bye.